Hi there, today we'll learn k-means clustering the easy, visual way. We'll see what clustering really is, how the algorithm works step by step, and where you'd use it in real life. No scary maths here, just pictures and simple ideas. So what's the big idea? Clustering simply means putting similar things into groups. Picture a messy pile of data. Clustering tidies it up into neat groups. Points inside the same group are similar to one another, while different groups sit far apart. Let's warm up by sorting some candies. We start with a jumbled mix all scattered together. Then we let the similar ones gather, reds with reds, blues with blues, greens with greens, until they settle into three neat groups. That's the heart of clustering. Similar things naturally belong together. Where do we actually use this? K-means quietly powers tools you use every day. It groups shoppers by what they buy, sorts your photos by what's in them, builds playlists of similar songs, and recommends items you might like. So what is K? K is simply how many groups you want, and you choose it before you start. With K equal to 2, you get 2 groups. With K equal to 3, you get 3. More K means more, smaller groups. Fewer K means fewer, bigger ones. Next, meet the centroid, the heart of each group. A centroid is just the center point of a cluster, like the group's captain. And since every group has exactly one captain, K groups always means K centroids. Here's the whole algorithm in 4 easy steps. Drop your centroids, assign the points, move the centroids, then repeat. The real magic is that steps 2 and 3 simply loop, and that's the entire trick. Step 1. Drop the centroids. First we choose how many groups we want, that number is K, and here we'll pick 3. This is our data, just a scatter of points with no labels yet. Now we drop 3 centroids onto the chart, shown as stars. For now we place them anywhere. They're only rough guesses, and we'll improve them in the steps that follow. Step 2. Assign each point to the nearest centroid. For every point, we measure its distance to each of the 3 centroids. Distance just means how far apart they are. The point then joins whichever centroid is closest and takes on that centroid's color. Watch as each point picks its nearest star, one by one. When we're done, every single point has a color, and that color tells us which group it belongs to. Step 3. Move each centroid to the middle of its group. A centroid's new home is simply the average position of all the points assigned to it, its balance point, like the group's center of gravity. So each star slides over to sit right in the heart of its own colored cluster. The little arrows show the journey from each centroid's old spot to its new one. Now they're perfectly recentered. Step 4. Repeat until everything settles. From here we just loop, assign the points, move the centroids, assign again, move again. With each round, the points get reassigned and the centroids shift a little less than before. Eventually, they barely move at all, and that's our signal to stop. When the centroids stop moving, the algorithm has converged, and the groups we see are final. It's that quiet repetition that does all the work. Now let's watch the whole process from start to finish. We begin with scattered points and 3 rough guesses for our centroids. Then the algorithm iterates assign, move, and in just a handful of rounds, that messy cloud organizes itself into 3 clean, stable groups. Simple steps, repeated, give a powerful result. That's K-means in action. Here's a tiny real example, grouping fruits by their size and their sweetness. We set K to 2. K-means discovers 2 natural groups, the small, sour fruits like limes over here, and the big, sweet ones like apples over there. And the best part, it found those groups entirely on its own, without ever being told the right answer. One important tip before you begin: scaling. We need every feature to speak the same language. Look what happens before scaling. Income, with its huge numbers, completely bullies the result and drowns out age. After scaling, both features matter equally, giving balanced, fair groups. So always shrink your features to the same range before running K-means. Now let's weigh the good things and the watch-outs. K-means is wonderful because it's simple to understand, extremely fast even on big data, and easy to put into practice. But keep a few things in mind. You have to choose K yourself. It's sensitive to where the centroids start, and it works best when groups are round and evenly sized. So when should you reach for K-means? It's perfect for things like customer segmentation, exploring brand new data, and compressing images. You might skip it when your groups have unusual shapes, or when you truly have no idea what K should be. Quick recap, you now understand how K-means works. Drop K centroids, assign every point to its nearest one, move the centroids to the middle of their groups and repeat until nothing changes. Then simply read off the colored groups. And that's it, you did it. Thanks for watching.